How do activation functions solve nonlinear AI problems? Imagine trying to draw a complex shape with just straight lines. It would be impossible, right? That's similar to what neural networks face without activation functions. They need a way to handle complex, curved patterns in data. Activation functions are the key to this. They are simple mathematical formulas applied at each node in a neural network. Their job is to transform the weighted sum of inputs into an output that can be passed to the next layer. Without these functions, the network would just be stacking linear transformations, which means it could only learn straight-line relationships. That would limit it to solving only simple problems like linear regression. But real-world data is often nonlinear, with curves, twists, and turns. Activation functions introduce nonlinearity into the network, allowing it to learn these complex patterns. Think of it like adding flexible joints to a robot arm so it can move in many directions. For example, the Sigmoid function outputs values between 0 and 1, making it useful for binary decisions. The hyperbolic tangent, or Tanh, outputs between -1 and 1, and is centered around 0, which helps with some types of learning. The rectified linear unit, or ReLU, is very popular today because it outputs 0 for negative inputs and the input itself 4 positive inputs. This helps the network learn faster and avoids the problem of gradients vanishing, which can slow down training. When these functions are used at each node, the neural network can learn to approximate very complicated functions. This ability is what powers AI models like ChatGPT for understanding language, DALL-E and Midjourney for creating images, and even productivity tools that interpret and generate content. From an ethical point of view, understanding how activation functions work helps us see how AI systems process information and make decisions. It makes the inner workings of AI more transparent, which builds trust. In essence, activation functions solve nonlinear AI problems by giving neural networks the ability to learn and representing complex relationships in data. Without them, many of the intelligent tasks AI performs today would be impossible.